Hey boys and girls, so today we're going to be going over Unit 1, Lesson 2, and Lesson 2 is Geometry Vocabulary. Before we do anything, the first thing I need you to do is just make sure that you write your name on the top of this page. It should really be on the top of every single page. That way when you upload your work, I can look for your name and you can earn that credit. Okay, as we look at some of the words here on page 1, I know we had discussed many of them yesterday in lesson 1. All right, so one of those words was the acute angle. So let's start off with going over the definition of acute angle and then maybe a few different diagrams of what it could look like. All right, so an acute angle is an angle, you got it, that's less than 90 degrees. All right, it's going to measure less than 90 degrees. So if I look at this example in our picture here, in our diagram, one of the acute angles that I'm seeing is angle ABC. All right, and that's something that we had gone over in our notes yesterday, how to name an angle. You always have to follow the order of the letters. I know A doesn't go to C, so I have to go in this specific order, either A, B, C, or I could call it angle CBA. All right, again, that's just a refresher from yesterday. There's other ways that I could draw an acute angle. I'm just going to include one more picture. I could have maybe an angle that, is upside down. Make sure you have those arrows at the end. And again, I know it's an angle because it has a vertex. It has that point in the middle. And we have two rays. I'm going down and to the left forever, down and to the right forever. All right, so my two rays with my vertex. Next, we have our obtuse angle. This one's a little bit different, looks a little bit bigger than an acute angle. So we're going to say that this is an angle that measures more than 90 degrees. It's greater than 90 degrees. All right. And again, if I look back at my diagram here, I can see that the obtuse angle that they gave me is angle ABC, or I could have said it's angle CBA. I just have to follow the order of the letters. And then again, I'm just going to include an example on the side here. So I'm going to draw an obtuse angle that looks a little wild and crazy. Maybe something like this. Again, I know I have my angle here because I have a point in the middle. That's my vertex with two rays. I'm going to the right forever and I'm going down and to the left forever. All right, so that's just another example of an obtuse angle. And then last but not least, at the bottom of the page here, we have what's called a straight angle. Now I know it looks like a straight line, and that's really what it is, but in geometry we refer to it as a straight angle. And you guessed it, you're seeing the number 180. This measures exactly 180 degrees. All right, so it's a straight line, has 180 degrees in the line. And again, I'm just gonna go ahead and highlight that for you. All right. Moving forward, just before I get to the next page, it would be helpful if you did have maybe two different color highlighters at home. Just for when we're going over notes like today, it's easy for you to highlight and see what's going on. I know everyone learns differently. I know that seeing things in color for me just helps me learn a little bit easier. All right, moving on to page 2. Okay. So page 2 at the top, again, it's just more vocab words. It's just another type of angle that we need to know. This is called vertical angles. All right, so let's read the definition so we know what our diagram should look like. It says vertical angles are formed by intersecting lines and they're equal in measure. So something like this is where I would stop and I would start highlighting and saying, okay, vertical angles is my vocabulary word. It's formed by intersecting lines and it's equal in measure. All right, so now I'm going to go ahead and draw intersecting lines to form my vertical angles. Here's an example of intersecting lines. It's just two lines that cross. It almost looks like a street crossing, like right at a corner. That would be an example of intersecting lines in real life. Okay, I know that a line goes on forever. This is something we learned yesterday. So I'm going to put arrows at the ends of both of these. All right. And now I'm going to go ahead and start looking. Well, I can see these two angles right here are by my intersecting lines, and I know that they're going to be equal in measure. These would be acute angles. So I'm going to say that this is a number that's less than 90. I'm going to say that this angle is about, let's say 80 degrees. So I'm going to put the number 80 on the left. But that means if this angle is 80 degrees, I know that this angle on the right is also 80 degrees because they're equal in measure. Okay? But then again, I know these two angles are vertical, and I know that they're equal in measure. So I'm going to say that this angle up top is 100 degrees. And I'm going to use two, I call them swoops, but they're also called arcs. Two arcs up top, two arcs down below. And I'm going to say that this is maybe like 100 degrees up top. So that means if the top is 100, this angle down below needs to be 100 as well, because I know my vertical angles are equal in measure. Now you're probably asking me, well, I don't know how that's where my vertical angles are formed. And I'm going to have you write probably the most important thing on the side here now. So under vertical angles, I want you in parentheses to put the word across. Vertical angles are always across from each other. So I do have intersecting lines, but it's the angles that are right opposite, right across from each other. So these would be vertical, which means they're equal, and these would be vertical, which means they're equal. You might also be wondering why I put those markings there. I just put one arc here and one arc over here to show that they're equal. Same thing with the top and the bottom. I put 2 and 2 just to show that they're equal. Okay, moving on. Next is complementary angles. Well, let's do the definition first. I know that complementary angles are two angles whose sum is 90 degrees. All right. And for anyone who might have forgot what the word sum means, it just means when I add them together. So I should be thinking addition. All right. Now I'm going to go ahead and just give us another example for our notes here. I know there's already a diagram, and it's telling me that if I add angle 1 plus angle 2, it should equal 90. And I know it's going to equal 90 because complementary angles are two angles that add to 90. Here are my two angles, angle 1 and 2. If angle 1 is 35 degrees, that means angle 2 would have to be 55 degrees. Because again, if I were to add angle 1, which is 35 degrees, plus angle 2, which is 55 degrees, that gives me 90. And that's exactly what I should have got because that's the definition of complementary. Now, don't go around telling everyone I'm showing you this trick, but I know that complementary angles add to 90 by using this little trick. If you look at the C in complementary, you might want to try to zoom in on this one. If you connect the C, now it looks like the number 9. And now I have 90 for 90. Boom. Isn't that amazing? You guys are probably like mind blown right now, and I'm loving it. Okay, let's move on to supplementary angles. Supplementary angles are a little different. So if we look right over here where we're going to write our definition, we're going to say it's two angles whose sum is 180 degrees. This one's a little bit bigger. All right. And again, the key word sum means to add. It means when I add them together. All right, here they already gave us numbers in the example, which is great. So I can see here that the number 60 plus 120 equals 180. And that's exactly what should have happened. Okay, I'm gonna share another trick with you. Keep it to yourself. Okay, if I look at the S in supplementary angles, you guessed it, we're gonna connect the S. So if I go ahead and I connect my S, well, that came out really sloppy, but it should have looked like the number 8 for 180 degrees. All right. So as long as you memorize one of these, you'll have to know the other one, right? If you can hopefully remember that complementary is 90, then of course supplementary would have to be the 180, right? That other number. These are probably the two most common numbers we use in geometry throughout the year. So it's going to be easy for you to remember both. Okay. And then moving on to our last word on this page, angles on a line. All right, so let's start off by reading the definition. It's adjacent angles on a line that are supplementary. Okay, I don't know if that definition helped us a whole ton, so we're gonna just break it down a little bit. I'm gonna highlight adjacent angles because that's a vocabulary word on its own, and I'm just gonna write on top of it, it means next to. So adjacent angles are angles that are next to each other, okay? And then I know that supplementary is a key word. We just went over it, and it means to add to 180 degrees. All right, so now I'm gonna go ahead and try to draw the diagram here. Well, the word is angles on a line. I think the first thing I'm gonna do is go ahead and just draw a line here. And again, I know a line goes on forever in both directions, so I'm going to include arrows on both ends. Now it says adjacent angles. So these are angles, as in more than one, that are next to each other. Well, right now I just have one big angle. Remember on the first page, this was called a straight angle, right? A straight line, a straight angle. But I need more than one. So I'm just gonna draw a little ray here to break it up for me. So now I have an acute angle on the left and I have an obtuse angle on the right. And I'm again gonna go one step further and I'm gonna add numbers to our picture just to give us an example to work with. So I'm gonna say, because this is acute, that this is 60 degrees. And I'm gonna say, because this is obtuse, that this is 120 degrees. All right. So I have angles that are next to each other, angles that are next to each other on a line, and they should be supplementary, which means they add to 180. So I'm gonna go ahead and double check. 60 plus 120 equals 180 degrees. So I know that this diagram is true. And then we have our example here for angles on a line. Now, I don't want to give too much information at once, but showing it to you early is just going to help you as we move through the rest of the year. A trick that a lot of us math teachers like to use when we have angles that are adjacent, right? Angles that are next to each other. When they're on a line, I start on the furthest part of the line, all the way to the left, and I draw like a half circle. So I move from one side of the line all the way over to the other, okay? And then I check to see how many angles am I hitting? How many angles are on that line? So usually I'm being cut by that ray. So I can clearly see that I have one angle here, two angles here, okay? That's how I know I'm adding just these two numbers together, and they should make 180 degrees. And I know they're gonna make 180 because one more time, if I look back on the first page, I know that a straight angle, a straight line, has 180 degrees in it. All right, So that's how I know that this is true. Okay, moving on to the third and final page. So close. All right, we have our perpendicular lines. All right, let's look at the definition again first. So I know that perpendicular lines are lines that intersect to form 90-degree angles. All right, and the symbol for that is an upside down T. So it's just a line and a bottom. So again, an upside down T. So now let's look at the diagram and we can start and go ahead and draw that picture for us. So I'm going to go ahead and just draw my perpendicular lines. And I know that they should be forming 90 degrees. So I want them to cross almost like a T, exactly like a T. So again, perpendicular lines. Lines go on forever. I got to add those arrows. And then the most important thing, when you're reading a word problem, the symbol would look like an upside down T. When you're looking at a diagram, the symbol is a box. So I'm going to go ahead and just add that box to our picture. Okay. And then just as a quick review, I'm seeing a straight line here. I'm moving from the left all the way over to the right. So how many angles am I hitting? Well, it looks like I'm hitting 1, 2, right? 2 angles. Well, if I know that there's 180 degrees in a straight line, right? This line should make up 180 degrees. If this angle is 90 degrees, well, what does this angle have to be? Exactly, you got it, guys. It's gotta be 90 degrees, which means I can actually add another box on the left because 90 plus 90 is 180. All right, and that's actually true for the bottom as well. This has to be 90, and so does this. All right, might be getting a little ahead of myself, but I just want to give you all the information now. Okay, next, all angles around a point. So I can see that I have a point in the middle here. It's going to be point B. I know that the definition for all angles around a point is when I add up those angles. When I find the sum of all the angles, it's going to equal 360 degrees. Whoop, angles. All right. So the sum of all the angles is 360 degrees. So if I have angles that are around a point, a little trick to help you with this specific question would be drawing a circle. So I'm going to go ahead and draw a circle on the diagram. You go ahead and do this as well at home. All right. And then I'm going to ask myself, how many angles are around this point? Well, I can see I have angle number 1 right here. I have angle number 2 right here. And then angle number 3. So it looks like I have 3 different angles. All right. And again, I know that all 3 of those angles should add up to 360 degrees. So I'm just going to give us a little example down below. If I were to add angle 1 to angle 2, and if I add that to angle 3, it should equal 360 degrees. All right. I also want to just quickly go over how we could name all 3 of those angles. Well, if I wanted to name angle 1, I'm going to call it A, B, D. All right, I'm going to put that at the top. Angle A, B, D. If I wanted to name angle 2, I might call it angle A, B, C. Angle A, B, C. And if I wanted to name angle 3, I'm going to start at D. I'm going to call it angle D, B, C. Angle D, B, C. And then one more time, you'll notice that the letter B is in the middle of all of them. because B was my angles around a point. That was the point that all my angles were around. And it's also the vertex of all three angles. All right. Two more to go. We have angle sum of a triangle. I'm going to go ahead and just stop and highlight angle sum of a triangle because we had already gone over that sum means to add. So I'm adding all the angles in the triangle. So here, they gave us an example, 50, 60, and 70. I want you to go ahead, and if you have a calculator on hand, or if you have your cell phone, you can just open up the calculator app. I want you to add 50, 60, and 70 and see what number you get. All right, so the sum of the three angle measures of any triangle, this is going to be true for any triangle. What'd you get? That's what I thought. You got 180 degrees. So there's 180 degrees in any triangle that you could make. All right. And then our very last word, angle sum of a right triangle. So this is specific for a right triangle only. So again, it's the angle sum of a right triangle only. Let's look at the definition first. It says when one angle of a triangle is a right angle, the sum of the measures of the other two angles is what? All right, now I don't know about you. I feel like I need to see a picture for something like this. So I'm going to go ahead and just draw a triangle to start. Now, I don't want to just draw any old triangle. I want it to be a right triangle. So I'm going to make sure that I'm including a right angle inside my diagram. Go ahead and draw one just like mine. Okay. So I know this is one of my angles. It's 90 degrees. So I know there's two angles left. There's the one up top, and then there's this one down below. All right. If I read the definition again, it says when one angle of a triangle is a right angle. Okay. One angle is a right angle. We're good. The sum, so when I add, right? Whoop, when I add the other two angles, when I add the measures of the other two angles, what number should that be? That's what this question is asking. Well, if this number we already know is 90 degrees, I'm just going to put a little 90 on the corner here. This looks like it's going to be an acute angle. All right, it's definitely less than 90. I'm going to say that this is maybe, I don't know, let's do 30 degrees here. All right. What did we just learn about the angle sum of any triangle? Well, I know that when I add all three angles in any triangle, it should make 180 degrees. So if this is 90 and this is 30, this number has to be 60 degrees because I know that 30 plus 60 plus 90 is 180 degrees. All right. So now if I read it again, if the first right angle, right, is 90, what's the sum? What happens when I add the other two angles together? Well, when I add 30 and 60, well, 30 plus 60 is what number? You got it. It's 90 degrees. So it just so happens that if you're working with a right triangle, if this is 90, that means when I add these together, it should be 90 as well. All right. Sometimes that comes up on the regions, so we just want to make sure that we're covering that with you guys. And it's something cool just to know as you're moving forward with your work. All right. And last but not least, page number 4. So one more time, anytime you get to the last page, it always says at the top, sometimes in the middle, but usually at the top, independent practice. Independent, it means it's on your own. So you are going to complete all of these questions on your own. You are then going to show all of your work as you are answering those questions. So for example, number 2, I can already see it says, find the measure of angle F. If you have to do some math to get this answer, we need to see that math written down on your paper. If the numbers aren't there, if the math isn't there, we can't give you full credit. So please just make sure you are showing all work. And again, one more time, make sure your name is written at the top of every single page. Maybe you should even right now just write name right at the top of your page to remind yourself to add it on. If you have any questions, you can always email us, or we shall see you in school. Have a great day.